Good morning and welcome to the live broadcast of Rocket Lab's 15th Electron launch, the in-focus mission for small satellite operators, Planet and Canon. We're coming to you live from Rocket Lab's Mission Control Center, where it's 10:04 a.m. and we're just 16 minutes away from liftoff at Rocket Lab's Launch Complex 1 in Mahia, New Zealand. My name's Dominic Vu, and I'm an assembly technician for the Electron launch vehicle.
And I'm Ariana Ryan. I've had a little bit of an upgrade since last launch, and now I'm a quality engineer supporting propulsion. Our launch operations team have been on site early today to prepare for this morning's scheduled liftoff at 10:21 a.m. New Zealand time or 9:21 p.m. UTC. Today's Electron mission is our fifth for the year, and it carries 10 Earth imaging small satellites bound for low Earth orbit. Inside Electron's fairing are 9 of the latest generation SuperDove satellites from Planet, the operator of the world's largest constellation of Earth imaging satellites. The 10th and final satellite on board belongs to Canon Electronics Incorporated and was procured for this mission by satellite rideshare and mission management provider Spaceflight Incorporated. Canon's Earth imaging microsatellite sets out to demonstrate some of the latest technologies the company has developed for satellite manufacture, including a middle-sized telescope equipped with ultra-high sensitivity camera to take night images of the Earth, and a small-sized telescope which is suitable for CubeSat use.
Earth imaging satellites play a huge role in helping us monitor change on our planet. They provide actionable data on things like climate change, monitor and respond to wildfires, and they can help farmers to better manage their crops to deliver food to our tables. Now, for more about how we get our customers on board, let's go to Launch Complex 1, where we have Mission Integration Engineer Jane McNichol at Range Control. Jane?
Thanks, Dom. It's great to be with you today on this beautiful morning on New Zealand's East Coast. My name is Jane, and I'm a Mission Integration Engineer here at Rocket Lab. Each mission at Rocket Lab is assigned a dedicated mission manager or integration engineer, and we work closely with our customers to help them through the mission process, from the time they sign up for a launch with Electron to integrating their satellites onto the launch vehicle to successful deployment on orbit. Now, I'm standing here today at Range Control, which is about 3 kilometers away from the launch pad itself and the payload processing facility, where the payloads for today's launch were integrated onto the launch vehicle. You can just make it out in the distance behind me. The payload processing facility is home to 2 state-of-the-art clean rooms where our customers can prepare their satellites for launch. But these clean rooms aren't the only ones that our customers can choose from. We have additional clean room facilities at our Long Beach, California headquarters for U.S. customers who want to integrate a little closer to home. And for customers launching out of Launch Complex 2 in Wallops, Virginia, we offer our brand new integration and control facility. Offering such a wide range of payload processing options is just one of the ways that we've created the most flexible and tailored launch surface for small satellites. But back to today's launch, the team on console have been monitoring the health of the launch vehicle, including the payload environment in the fairing, as we progress through the count. All systems are currently green, and very soon Canon 2 and the 9-planet SuperDoves will be on their way to orbit. Back over to you in Mission Control.
Thanks, Jane. So, you're currently looking at a live view of Electron on the pad at Launch Complex 1. Electron stands 18 meters tall and weighs about 13 tons at the moment of liftoff. Electron itself is actually incredibly lightweight due to its black carbon composite structure. Almost the entirety of the rocket's first stage is filled with a mix of propellants for the Rutherford engines. Now, of that 13-ton liftoff mass, around 12 tons is actually the liquid oxygen and kerosene that fuels Electron on its way to orbit. The white stripes you see along Electron indicate where the liquid oxygen is being loaded inside the tanks. Because of the extremely cold temperatures of the oxidizers inside, any moisture on the outside of the rocket freezes in its place and causes those white stripes of ice to appear.
As we approach T-minus 12 minutes, let's check in with Mission Control for the final go, no-go poll.
All right, to all stations, this is LDR mission. We are now proceeding with the go, no-go sequence. Stage, you go.
Stages go.
Avionics.
Avionics is go.
AFTS.
AFTS is go.
GNC.
GNC is go.
VCON.
VCON is go.
RF.
RF is go.
T1.
T1 is go.
GC.
GC is go.
BLS.
BLS is go.
RSO.
RSO is go.
Net.
Med is go.
MM,
Go.
LD sub,
LD subs go.
and exec.
The exec is go for launch.
And all stations, go no go sequence is complete. We're currently T-minus 11 minutes, 20 seconds and counting. We're go for the terminal count start at T-minus 10 minutes. From this time, the three-way procedure is in effect.
Green across the board, Electron is go for flight. So, Electron is a two-stage to orbit vehicle. The first stage is powered by 9 3D printed electric pump Rutherford engines, which are designed and manufactured in-house by Rocket Lab. So Ari, as our resident engineer in propulsion, why don't you let us know a little bit about the Rutherford engines?
I'd love to. When Electron was first launched in 2017, these Rutherford engines were introduced as an entirely new type of rocket engine, due to how its propellants are pumped by an electric motor powered by batteries. Today, the Rutherford engine remains the first and only electric pump-fed rocket engine to fly to space, and with this mission, we'll have flown 150 Rutherford engines. The Rutherford is also the first oxygen hydrocarbon engine to use 3D printing for all its primary components, including the thrust chamber, injector pumps, and main propellant valves.
That's right. So for the second stage, Electron uses a single vacuum optimized version of this engine. And once it's in orbit, Electron's third stage, also known as the kick stage, takes over and carries out the final leg of the journey to deliver our customer satellites to precise custom orbits. Now, Electron is the only launch vehicle that delivers this dedicated, direct-to-custom orbit service for small satellites, even when flying on a rideshare mission. This provides a streamlined path to orbit for our customers and eliminates the added risk, complexity, and cost of having to develop your own spacecraft propulsion or using a third-party space tug to deliver your spacecraft to the desired orbit when flying as a rideshare.
Electron's kick stage, which also serves the foundation for our family of Photon satellites, employs our in-house design and manufactured Curie propulsion system. This 3D printed pressure-fed engine has a flight heritage across more than a dozen orbital missions. It's this unique and reliable propulsion system that ensures the kick stage provides our customers with unmatched flexibility for orbital deployment. It enables orbit raising, orbit phasing of multiple payloads on a single mission, deployment of multiple payloads to different planes and inclinations on the same mission, hosted payload support, and sustained low altitudes. It also enables deorbiting to avoid contributing to the growing issue of space debris.
This band is switched to high power for flight.
All engine blips are nominal, engines are ready, and stage terminal checks are complete.
Thank you, stage.
Stage 1 and Stage 2 high voltage batteries are ready for flight.
Copy avionics. GC, LD on mission, please proceed.
In around 8 minutes time from LC-1's Pad A, Electron will launch in a southerly direction along the east coast of New Zealand, making its way to sun-synchronous orbit and deploying the payloads at an altitude around 500 kilometers above Earth. At about 2.5 minutes after liftoff, the Rutherford engines on the first stage will shut down before the vacuum engine on stage 2 ignites, continuing the satellites to orbit. At around 9 minutes after liftoff, that second stage engine will shut down and the kick stage will separate from the vehicle in preparation for payload deployment, about 60 minutes into the mission. Now, when the kick stage separates from Electron's second stage, it will be in an elliptical orbit around Earth. So after a coasting period, the kick stage's Curie engine will ignite to propel the payloads into a circular orbit around the planet, ready for deployment into their precise and individual orbits. Now, since we won't have live footage of that payload deployment, we'll be ending today's webcast shortly after kick stage separation, at around 10 minutes after liftoff. You can continue following our mission via our social media channels, where we will post confirmation of payload deployment.
AFTS is green and enabled for flight.
Q avionics.
Right now, we're at T-minus 6 minutes to launch. And a quick update on the weather. It's a little cloudy out there today, but we are currently go for launch. Our range control team at Launch Complex 1 has also given the all clear with the vehicle and systems healthy on the pad. Things are looking great for an on-time liftoff today at 10:21 this morning, New Zealand time.
We're excited to be on the pad, ready for another Electron launch. In the world of disruption caused by COVID-19 this year, we're proud to be continuing to serve the small satellite community with timely and affordable access to space. Assured access to space is something that governments and commercial satellite operators alike need to be able to rely on, no matter what disruptions the world might be facing. It's the very reason we developed the most resilient and responsive satellite launch systems ever created. Now let's take a look at how we made that possible.
2 launch complexes, 3 launch pads, across 2 countries. This is how Rocket Lab makes truly responsive access to space a reality. The world is increasingly reliant on small satellites to power our economies, to provide scientific insights and data, and to maintain national security. The satellites providing these vital services are vulnerable, be it from natural, accidental, or deliberate actions. The ability to deploy new satellites to precise orbits in a matter of hours, not months or years, is critical to maintaining a resilient space architecture. The loss of a single satellite can have far-reaching consequences. It's why Rocket Lab developed the most responsive satellite launch system ever created. And it all comes down to resilience in numbers. Between Rocket Lab Launch Complex 1 in New Zealand and Launch Complex 2 in Virginia, USA, we can support more than 130 launch opportunities every year. It's an unprecedented level of launch availability that enables rapid replenishment of orbital assets. Resilient space is about being able to respond to evolving situations in real time. It's about having the ability to launch more than one rocket, in fact 3 rockets, from different hemispheres, simultaneously, a capability unique to Rocket Lab. It's about eliminating the fragility and complexity associated with mobile launch infrastructure, and instead enabling instantaneous launch windows from pads that remain in a state of launch readiness 24/7, 365. It's about delivering responsive and affordable launch services tailored to every mission, every time. Welcome to the future of resilient space.
We can't wait to be hosting the webcast for simultaneous missions on LC-1 in New Zealand and LC-2 in Wallops. But for today, we're focusing on LC-1.
As we approach the targeted liftoff time, we're going to hand you over now to listen in on comms from Mission Control for the final minutes until launch.
Performance is good.
LD on mission. We are go for auto sequence start at T-minus 2 minutes. And I can confirm at this time LD is go for launch. Entering auto sequence.
Vehicles on internal power.
Lock load is complete. Starting recirculation. Anti-gas ring disabled.
Stage 1 tanks are pressed. And stage 2 tanks are pressed as well.
High flow engine purge is enabled. Deluge is activated.
T-minus 20 seconds and counting.
In 5, 4, 3, 2, 1.
Stage 1 propulsion is nominal.
HVB battery discharge nominal.
And there goes Electron for our 15th launch from Rocket Lab Launch Complex 1 in New Zealand. We're T plus 50 seconds and Electron is approaching max Q, or maximum aerodynamic pressure, the moment during its ascent when the forces against the vehicle are at their strongest.
Cleared maximum dynamic pressure.
Enter chevron 2. Enter chevron 3.
AOS at Chatham Station.
Next up will be 3 events in quick succession. We should hear the call for MECO as Electron's Rutherford engines throttle down to allow for stage separation before the engine on the second stage fires up to continue the mission to orbit.
Entered stage 1 burnout detect mode. Separation confirmed.
Stage 2 ignition confirmed.
Successful MECO confirmed by Mission Control. Propulsion is continuing nominally on Electron's second stage at T plus 3 minutes into the mission, with the vehicle now travelling at several thousand kilometres an hour. Soon, the fairing halves will separate and you'll be able to watch them fall away on your screen there. And there they go. Electron has successfully jettisoned the fairing and is continuing nominally towards orbit.
Stage 2 propulsion is nominal.
For those of you just joining us for today's launch for Canon and Planet, we've made it through liftoff, main engine cutoff, stage separation, and stage 2 ignition. Electron is traveling through space at 9,000 kilometers per hour and is currently at an altitude of 153 kilometers.
While we're coasting through the vacuum of space, let's delve a bit deeper into Rocket Lab's engines. Each of the Stage 1 Rutherford engines weighs around 35 kilos or 77 pounds and comes in at around 800 millimeters or just under 3 feet. A Stage 1 engine is capable of 24,000 newtons of thrust. Stage 2 is the same base engine with an extended nozzle. This vacuum nozzle increases the size of the engine twofold and adds an additional 1,000 newtons of thrust.
Another quick check-in from Mission Control. We're T plus 5 minutes into the flight and the Electron is continuing nominally through its second stage burn. Electron's next action will be to swap out the onboard batteries for a fresh new one in what's called a battery hot swap. Let's listen in for the call of that swap.
HBB battery discharge nominal, approaching hot swap in roughly 30 seconds.
Throttling down.
Hot swap successful.
Battery ejection confirmed.
AFTS is safe.
And we've had a successful battery hot swap. Electron's second stage engine continues to propel the payloads towards their targeted orbit.
Stage 2 propulsion still holding nominal.
HVB battery discharge holding nominal.
We're at T plus 7 minutes since liftoff. In the next minute and a half or so, Electron's second stage Rutherford engine will power down before shutting off. We call this SECO, which stands for second engine cutoff, and this allows for a clean separation of the kick stage. Then, the kick stage will light its Curie engine and continue on its trajectory, coasting for a time before relighting its engine to carry the satellites closer to their optimal position orbiting Earth. We'll be ending the broadcast shortly after we hear confirmation of successful SECO and stage separation.
Okay, entered stage 2 burnout detect mode.
Guidance is in terminal, 20 seconds remaining.
And seeker confirmed.
You can see the engine on stage 2 has shut
Separation
down.
confirmed.
We're now waiting for
Transfer
kick
orbit is
stage
nominal.
separation. We've just had confirmation that the kick stage has separated. With another 40 minutes or so until that final carrier engine relights, we're going to end the launch broadcast here ahead of payload deployment. We'll share the news of mission success on our Rocket Lab social media channels within the next hour.
Thank you to our smallsat customers, Planet and Canon Electronics, for choosing to launch on Electron today. I'm Ariana Ryan.
I'm Dominic Vu. This is Rocket Lab Mission Control, signing off.